Hello everyone, this is Sterling Celestine, Assistant Professor, Department of Mathematics, St. Josephs College of Arts and Science for Women. In this video, we are going to see small sample test 2. Okay, in that we are going to see, especially we are going to see goodness of fit test. Goodness of fit test is a powerful test for testing the significance of the discrepancy between theory and experiment. That means between the theory, what the theory they have given and what experiment we did, between these two, there will be is there any differences are there or not, and how much importance we can we give for that differences that we can test by this chi-square test of goodness of it. This was first given by Professor Carl Pearson in 1900. It enabled us to find if the deviation of the experiment from theory is okay. That difference I told from the theory that experiment there will be a difference. It will come. I told whether it is by chance and it is due to the lack of the explanation of the theory or lack of the observation data of the theory. We will tell by this goodness of fit test. Okay, for that we are taking two set of two set of frequencies. One is Fi, that is observed frequency, and another one is Ei, that is expected frequency, corresponding set of expected frequency. Okay, that expected frequency we can tell that theoretical or hypothetical. Okay, then Carl Pearson's chi-square distribution is given by. Okay, chi-square is nothing. Chi-square distribution is nothing but the square of the normal standard deviate, normal standard variate. Okay, normal standard variate we know is it equal to summation xi minus mu by sigma. Okay, for that if we take the square, then we can say this as, chi-square variate. Chi-square variate or chi-square distribution and then. Okay, if we test this chi-square, then we can say that is chi-square test. Okay, so chi-square is equal to summation Fi. Instead of mu I, here we have Ei divided by the Ei. Okay, this is the chi-square distribution with the n minus 1 degrees of freedom. Okay, for that decision rule, how can we take the decision whether this the both frequencies are equal or either is there any distribution? How can we say? Okay, now first we will take the null hypothesis. Okay, in that we have the calculated value and we have the observed value. So that means tabulated value. If the tabulated value is less than the calculated value, then we can accept the decision. Otherwise, if the tabulated value is greater than, then we can reject the null hypothesis. Okay, where calculated chi-square is the calculated value of chi-square obtained on using equation 1. By using this, what we can tell that is chi-square. And about the level of significance and degrees of freedom, what the tabulated value they have given, that is the chi-square alpha of n minus 1. Okay, now we'll see. According to this, we'll see a formula. Sorry, we'll see an example. Okay, the demand for a particular spare part in a factory was found to vary from day to day. Okay, in a factory, if they are manufacturing the spare parts, if it cannot be same for all the days. Okay, it will vary day to day, or it cannot be same for the particular day. That means Monday, Tuesday, Wednesday, like this. Here they are telling that is very day to day. In a sample study, the following information was obtained. For 1 week, they have obtained they have studied and they are telling this informations. Okay, now they told us to test the hypothesis that the number of parts demanded does not depend on the day of the week. Okay, according to the day of the week, the spare parts does not demand. Okay, it is day to day, it can be changed. given the values, they have given the chi-square significance at 5% level of significance. That means if chi-square level at 5% level of significance, chi-square value is degrees of freedom is 5, then the value is 11.07. If degrees of freedom is 6, then 12.59. Degrees of freedom is 7, then it is 14.07. Using this, we are going to see the values. Okay, first we set up the null hypothesis sketch in R. What null hypothesis? The number of parts demanded does not depend on the day of the week. Okay, does not depend on the day of the week means what? It cannot be depend. Monday means 1124, Tuesday means 1125, Wednesday means 110. Like that they have given. No, this is not according to the particular Monday or particular day. Okay, it can be in the one Monday 1124, another one Monday it can be changed 1325, 1785 like that. For one Monday 1124, for another Monday it can be 1375, or another Monday it can be 976. Like that it can be changed. They are telling to us. Okay, now we'll see. Okay, now we'll see the proof. Okay, we are setting the null hypothesis like this. So under the null hypothesis, the expected frequencies, we have to see the calculated frequency and the observed frequency and the expected frequency. Observed frequency, they themselves, sorry, observed frequency they themselves have given. Expected frequency we want to find out. Okay, expected frequencies of the spare part demanded on each of the 6 days. So expected frequency, how can we find out? From the observed frequency, what is the mean value? That is the expected frequency. So there are 6 days, Monday to Friday, Saturday, that is 6 days. So 1 by 6, 1 by n is 1 by 6. So expected frequency, so EI, expected frequency EI is nothing but summation Fi divided by n. Okay, using this formula, we are writing this one. So, using this formula, we are writing 1 by 6 into all the 6 values which are given in the question itself. Okay, and we are getting 6720 by 6. We are dividing this by 6 and we get 1020, 120. So this one we are put in the tabular column. Days they have given, observed value they have given, expected value we have found out. Okay, then now we are finding out the Fi minus A. This is the formula we have to find out. So first we are finding the numerator Fi minus A, the whole square. Fi minus A, 1124 minus 1120. The difference is 4. The difference between this is 4. If I square this one, I can get 16. Like this, the difference between is 5. So if I square this one, I can get 25. For this, it is 10. If I square this one, I can get 100. For this, it is 0. If I square also, I can get 0 only. Again, for this, it is 6. Okay, if I square it, I can get 36. For this also, the value is minus 5. Okay, the value is minus 5. If I square, I can get the positive value 25. Okay, now what I'm doing is I'm dividing this by the EI value. Okay, each value I'm dividing by this EI value. Our EI is same for all. So all the values I'm dividing by 1000. 1120. Okay, so okay, now we'll see here we have to divide this value 16 divided by 1120. Okay, we are getting 0.014. So here there we have seen in the calculator we have seen now we are dividing 1120, we are getting 0.1 0.014 something. Likewise we are dividing all the values by 1120. Okay, then we get the values, these values Okay, at last what we are doing, we are adding. Okay, we are adding. First we are adding the observed value 6720, expected value 6720, and this value 0.179. Okay, now we'll see. Okay, the chi-squared value summation fi minus ei the whole square by ei is 0.179. Now we see the degrees of freedom. N1 minus 1 is the degrees of freedom. So they have given n value is 6 days, so n value is 6, so minus 1 is 5. But since we are given 6 frequencies subjected to only one linear constraint, so therefore summation fi is a summation e is also 6720. Okay, the tabulated value in the question itself, they themselves have given. Okay, for the degrees of freedom 5, okay, the value is 11.07. Okay, 11.07. So the tableted value is 11.07. Okay, in the definition we have seen, okay, we can accept the null hypothesis if the calculated value is less than or equal to the tabulated value. Okay, now we'll see our calculated value is 0.179. Our tabulated value is 11.07. This is less than this one. Yes or no? Okay, this is chi-squared. Okay, and this is chi-squared alpha. Alpha is level of significance and degrees of freedom n minus 1. Okay, degrees of freedom n minus 1. Okay, this is for our problem. This is 0.179, and for our value this is 11.07. So this is less than or equal to this one. So we can accept the null hypothesis. So we can accept the H naught. Okay, wow. So we can accept the H naught since calculated value is chi-squared is less than the tabulated value. Okay, that means 0.179 is less than 11.07, and it is not significant, and the null hypothesis may be accepted at a 5% level of significance. So what is our null hypothesis? Okay, our null hypothesis is number of parts demanded does not depend on the day of the week. Okay, hence we conclude that the number of parts demanded are same over the 6-day period, and it does not depend on the day of the week. Hence the solution. Thank you.